Today, the main topic is on human-centered design. Just briefly to mention, the slides I'm going to talk about today are built off of a couple of tutorials that I saw from Di Yang, and I think very helpful in setting up this material. It's not my core area, but it's an area that I'm sort of learning a lot about, and I think it's pretty central towards some of the things that I think are important in this course and relevant material more broadly. And so mostly we'll try to focus on perspectives and methods from human-centered and human-computer interaction and how they might play a role in thinking about questions and, to fix this thing, of a human AI type of settings. And it'll be a bit of a departure from a lot of what we've covered so far. I've been primarily methods focused, but I think part of my goal would be to say something about how most of the topics in this class as a sort of technical area fit into the scope of, or the narrower scope of focus. And I'll speak of the class as a narrower scope, and then the HCI is maybe a potential broader way of thinking about the kinds of questions that we're interested in solving. Okay, so if you're not familiar, so human-computer interaction is broadly discipline that thinks about designing technology from a human perspective, and is distinguished as compared to what I'd argue most of engineering and computer science is good at, which is starting with a sort of engineering problem and solving directly there. Of course, I'll just actually say this ahead of time. I'm going to take somewhat caricatured extreme perspectives on many fields in order to make a point. Indeed, everything is much more of a spectrum, so things are not nearly as extreme as all this. But a way to think about it is applying the scientific method to the art of design. And by Nielsen, the rest of the code is to illuminate paths that people actually walk. So maybe set up the problem is an interesting example of something called Norman doors. So, come across a door, potentially you tried to open it and you tripped. Imagine many of you have had versions of this experience. I have, some of you have. And some of the issue might be not knowing exactly how to operate it. So, is it a push or a pull? It's maybe not obvious. So it has a handle, but what the handle does is not clear. So multiple places that you could engage the handle, but it's not clear which one of them is actually the right tool to use. Or it doesn't push or pull, like neither is right. It's actually a sliding door. So you need to know that it's something you're supposed to slide. And there are many ways to think about this. You could say, we're not clever enough to engage with technology. I think I'd argue, and the thesis of this lecture is that that's not the right way to think about this problem. The right way to think about this problem is that it's bad design. So, there's some infrastructure in the world, in this case, doors, but broadly includes technology, things like artificial intelligence tools that we're building. And they don't work for people. And the argument is they don't work for people because they're not designed appropriately. And so one could think about what can be done differently to help them work better for people. And I'd argue that a lot of what this class is about, at least the framing I'll take, though I think there might be other ways to think about this, but the framing I'll take is that learning from human preferences is a powerful tool as part of the toolbox of building AI technologies that work better for people. So, this is a bit of an analogy, but you could think of, by the way, Norman is the author of the book at the bottom, that's sort of framing of this design thinking approach. But as mentioned, you can think about this within AI, not just about doors. So for instance, for a door, the question that you're interested in asking is, how do I get into a room? So push, pull, slide, all that stuff. But the AI had some version of, at least for most people when engaging with AI technologies, the question of, how do I solve a particular task using some AI tool? And so that's the sort of what the user wants to do when engaging with the technology. There's also, what the user actually ends up doing. So this is, maybe asking themselves, how do I operate the door to actually get into the other room? So this is a standard thing. And AI, maybe, given we're in 2024, specifically maybe in language models, the main affordance, the main way we engage is maybe what's the special prompt, magic prompt I need so that I can get this language model to do the thing that I want it to do. So again, in some ways, it's the way the world is now, but I think one might argue it is really weird that this is the way the world is. Like, we built this tool ostensibly to solve various kinds of tasks, but the way that we have to engage includes this mental gymnastics of, can I create some magic prompt that does something? And then finally, there's the question of, user engages, maybe learns over time, and then answers this question of how to actually learn to use this tool. And in built environments, things like doors, might be things like learn from previous encounters. Usually, if you bump into a door, you won't bump into it again, at least not in the near term. Maybe if you forget it, you're not thinking. Or you read labels, or you guess maybe your most likely thing that might work, and then try again, and hopefully it works eventually. For AI tools, might be things like, there's now there's a word for it which isn't coming, but special sauce about how to create good prompts. Talk to other people. It's a bit of this extra art thing that's not science, but not science. People talk about this magic prompt that does a certain thing. Or someone else has, people have done these prompt guidelines. There are a bunch of influencers, as you may know, have done these guidelines for how to create magic prompts. And many of them effective because, again, there's a real problem that people are trying to solve. Or I'd argue most of us just sort of play till we figure out something that works. The thing to highlight here, though, again, this is a real problem in AI technology as it's used. And the argument here is that in a at least well-designed world, it's reasonable to argue that this shouldn't be a problem. Like, this is a failure of our design of the tool, that there's this key part of engaging that requires this sort of messy, unclear process, also unclear outcomes, right? Because you actually don't know what you're going to get. And I'll engage a little bit on the prompting thing in a little bit. Any questions on the setup? So this idea of design broadly, maybe this analogy between doors and built environments and sort of AI technology. Yes.
I feel like for doors, or like more broadly, maybe the people who built the door would have a good understanding of it.
That's a good point.
I don't know if that extends. I honestly don't know if that extends.
That's a fascinating point. So I guess there's an argument that in addition to the design issue, one of the reasons why blame is easier, I'll infer from your question, is that in the door setting, we could argue that the people designing doors know a lot about doors. And so the gap there is partially just not making it easy for users to engage. And I think your argument, I'm repeating, but I think accurate, that in AI, part of the gap is that we don't know that much about the internals of the tools. Yes and no. I'll give some examples of some ways that one can close some of this gap. That'll be actually the main thesis of the talk today. I think you're right that we don't, I guess we know we don't know. Is this mix of knowledge, some scientific, some emerging, some folklore about what works and what doesn't work. I think it's a little bit separate from how can we make it in tools that are thought of as stable enough to be products, for instance, and released in the world. Are there affordances? Are there things that can be done to make them easier to use? And the main argument will be, or at least part of the discussion today will be, I think yes, even though we may not know all of the internals. So it's not clear to me. For sure, it makes the problem harder. For sure, there's some interventions that would be straightforward in a door setting that would be unclear. In particular, a lot of our tools will build on some optimization technique, which we hope works and is stable and so works appropriately across contexts. And so there's maybe some brittleness in some of the ways that we can mitigate some of these issues. That may not be as bad in the door case where you deeply understand the technology. I think that's fair. But I want to separate that from trying it all and sort of building tools so that they're usable and better designed. Excellent point. Thoughts, questions? Okay, so one could argue that the goal should be, in fact, if a technology is designed well enough, you should actually not know that a lot of effort was put in. It's actually one of these weird things where the more you're deeply aware of the work, likely the worse the actual technology is. And somehow you get no credit if you do a perfect job because it disappears in many ways. And so this quote from Mark Weiser says, "The most profound technologies are those that disappear, that weave themselves to the fabric of everyday life until they're indistinguishable from it." So I think, partially this is also part of, I feel like, human psychology, where once things get easy and straightforward enough, it comes to the background and it's automatic. And we're not thinking hard about a particular way of engaging with technology. So we're just used to it. Some of this can come from practice and overall engagement. I'll give some examples there. But I think a lot of it can be just better designed such that it's just intuitive. There's not a big learning curve for engaging with technology. So, for instance, you don't require an instruction manual. You use it once or twice and, you will barely feel it, or at least you never think about having to figure out what to do from that point on. So, some good examples of this might be things like various kinds of pointing devices, even though mine does some weird things today. Okay, now actually not working. So. It's a different issue. Things like touchscreens. I think this will actually work. Okay, so it does work. Yeah. Again, technologies that are intuitive, and part of the discussion would be about ways in which AI technology itself can be made to be more intuitive and easy to engage with. And then we'll dabble, or at least mention, some of the ways that some of the preference work that we've been going over might make this more effective. Okay, so how do people who think about this think about this? So one way to think about it is to think about bridging the gap between what humans can do, or human function broadly, humans engage with technology or tools, and then what computers may or may not be good at. And both axes are important because technology evolves and gets better over time. And I think as it gets better, it makes it easier to think of, often as it advances, it often makes it easier to imagine ways that you could better bridge the gap between technology functioning and human functioning. So, on the direction of extending computers, you can go all the way from early technology like punch cards, which were actually literally the way. I have seen a punch card. I've never used one. I'm going to stereotype and say none of you have used a punch card either. It's possible, but I'll be surprised. The way the technology actually got built, all the way to command line, which still useful, but requires high expertise. And so useful for settings where that's the ideal, but arguably has moved over time to things like GUIs, they're sort of graphical user interfaces, easy for people to engage with, pictures that look like the thing that they want to do, pointing devices, touchscreens, all that stuff. And so one way to think about, of course, some of this is explaining technology after the fact. I think a lot of this is really, though, technology built to meet certain needs, to make it easier for people to interface with computers. But the argument here is that this is one of the ways that, particularly in personal computing, we've been able to make some effort into bridging the gap between some of what computers initially were good at to some of what humans find easy to do. And so it's sort of ubiquitous and easy to engage. And so on the GUI, some of the thinking would be things like, as I already mentioned, metaphors for objects. So the icon looks like the thing you want to do. For pointing devices, things like actions that you want to take and making that somewhat intuitive. Arguably, this is a lot of effort done in this, in phones, for instance, to make them more and more intuitive and easy to use. As you know, a lot of this is evolving, so there's more and more technology being built, often with the express purpose of making it easier to interface with technology. So we'll see where things go, but a lot of work in VR, AR, stuff like that is, you could argue, is again trying to figure out this bridge, making interfacing with computing easier. Yes.
I guess what's the difference between the extending human versus extending computer? Like, what's the distinction exactly there?
Yeah. So I think it's more. This will come back again in a little bit, but the story being told here is on one side of things. So I'm calling it a story because, to your point, and maybe to this discussion, part of it is just naturally technology getting better. Part of it is intentional design thinking to make it easier for people to engage. And I'm focusing on the second part, which is the intentional design thinking. And so the story being told here is, punch cards and command lines partially were a result of what was available and possible to do when computers first became a thing. But also, the reason that interfaces changed was intentionally as a way to bridge sort of easy human cognitive processes and sort of ease of interacting. So the point being made, or maybe I'll tell a different story. There's an alternate world where technology got better in the ways that, arguably many of us in this room will think of technology getting better, get faster, all the things GPUs do, for instance. So a better and better GPU doesn't necessarily help a user, and it very indirectly helps the user's experience. There's a difference between thinking of the computing effort as just making computers more, better at being computers at some metric that we've decided or what a good computer is, speed, parallel processing, things like that, versus intentionally trying to think through what makes it easy for people to engage with technology, and then what can we build to make that interface and engagement easier. That's the sort of analogy and distinction I'm trying to share. Excellent question. Thank you. Cool. Okay. So, arguably we're on this road, and there are many people whose job it is to actually think about this within computing, how to build interfaces and things like that. I think more and more so, some of these questions are starting to come up in the AI world as well. So, as a part of technology, but specifically building machine learning, artificial intelligence tools, this question of what it means to get a better AI tool from a purely technical, like just it has a better AI tool, versus what it means to make it easier for people to interface with the AI tool and sort of solve problems that they're interested in, assuming that's the main motivation for this. So, from the AI side, many of the early ways of engaging with AI technology required that you're an expert, essentially. So you're writing code as a way to engage with the tool. Now there's a bunch of prompting. So, it's not, it doesn't need expertise in the same exact way. It's a different kind of expertise, but it is still like a somewhat specialized skill, as we've already discussed. And arguably chatting, while related to prompting, sometimes some of the interfaces are brought up in ways that are maybe less specialized and easier for people to engage with, I guess mostly language technologies here, but I think this is also true for many AI technologies. I think we are in many ways bridging the gap in usability, at least by the story, meaning the gap from using code as a way to interface to using prompting as a way to interface to now maybe using chatting as a way to interface. In some ways, a lot of success is driven by the fact that it's partially just easier for people, particularly non-expertly trained people, to think about solving real problems with these tools. I think part of the argument here is, or there's an explicit argument here that this is not complete. There's still more. Arguably these things are maybe never complete. The whole point is make it easier and easier. But the chasm seems wider here than it does maybe in general computing. And like, what are the interfaces and what are the affordances that can be built that make it easier for people to use AI tools to solve problems that they actually want to solve? Yes.
What do you think about Neuralink, for example?
This is a good question. So Neuralink being, technology to directly plug into your brain, and I guess it's not obvious to me that it's built specifically for AI. I think it's more for, as an interface choice, maybe. Of course, any interface choice has an impact, or will likely have an impact on AI technology, because it can just be like the endpoint. It's an interesting idea. It's an interesting idea. I think practically now I'm just speculating wildly, but you asked, so I'm happy to speculate wildly. I think adoption will take some time. I think different people will have different amounts of ease of imagining like something implanted in your brain as a way to interface with technology. I think the current technology is very impressive. It's not so easy to use that it sort of completely solves the problem. So yes, you can think about, but my understanding, and this is not from expertise, it's from a few conversations and maybe looking at a few things, that you do need to be thinking sort of fairly specialized. Like it's still quite limited in the bandwidth and how you can interface with technology as a computing interface device. So, could one imagine something implantable that if, eventually makes it just intuitive and easy? Perhaps. I think there are lots of fun problems that seem additional to the technology problems to that being ubiquitous, which one is just fixing technology such that it's really, truly easy to use. But also it's the social governance problem, which I think will be fun. And who's ready to go under, get something implanted in your brain? It's still a risky procedure. I think it's still to my knowledge, people that have been most positively affected by other people where really it's solving an explicit problem because there's some disease or neurological disorder or something else that they can't actually literally interface with the world. And this is the thing that's solving. Which is a very different ask, maybe. Extremely important and solving a need. But I assumed you said it in the context of like, will this be the ubiquitous technology that bridges the gap? And both technology needs more work. I think there's also social governance things that would be interesting to solve if that's the way. At this point, we're speculating. Yeah.
How much of human functioning, or like, can we consider like education? Like, I guess in the example of learning how to read.
Yeah, no, that's a good question.
You never have to learn how to read.
Yeah.
It's just like dictated to you.
Yeah. Yeah, that's a good question. And I think correctly noted that it's a bit fuzzy in the description here because there's this assumption that ease of use is a zero learning curve thing, whereas there's a societal context and many people that use technology are sort of educated a certain way. And so, for instance, typing or I guess pointing maybe doesn't necessarily need specialized education, as my kids have taught me. but like typing or other or also just knowing the right questions to ask or what you want to solve, right? Sometimes I think it's an interesting question. I think it depends on. I mean, it's a non-statement, but I think true. Depends on the setting, context, and all that stuff. I think the way I want to think about it here, though, is I think a good target. Actually, we'll get to some specifics tied to this. I think the right way to think about these questions are really deeply contextualized. So, who are the people? What are you trying to solve? How do we solve the problem for these people? And once you get to that level, at least the way I think that this kind of work, or at least the design thinking work, is sort of best framed. Once you get to that level, you're taking into account people's educations and to some extent leave the experiences if you can. We'll talk a bit about equity issues, which I think also partially points to this. So this question of if I'm designing for a particular set of people, am I leaving a bunch of other people that could benefit out? I think that's some other hard questions here. But to your point, it for sure has an impact. I think part of the goal, despite the very high level discussion here, I think part of what I'll motivate a little bit is contextualizing. And I think contextualizing forces that you think about who your audience is. And then maybe specifically thinking about how do I broaden the scope between making education less of a factor, for instance. I think that's a good point. Cool. Anything else? Yeah. Good discussion here. I guess all the design people showed up today. That's great. Okay. So to this point, I think arguably what many of us are best at are really pushing on technology for technology's sake. Like I want to just get a good tool to, we have some definition. We may or may not be accounting for users, or we have some abstract notion of users that are not any kind of real user. It's sort of, some abstracted metricized user often, like this is a number that we're chasing. And so we can call this technology-centric design. It can be useful on its own, particularly when there's already technology and there's a bunch of sort of well-established maybe norms or ways of engaging. And so fully pushing purely in technology is actually very reasonable. I'd argue a lot of AI work is sort of roughly in this space, a lot of like pure computing work, like how GPU questions that we talked about earlier are in this space. The arguably other side of it is instead of centering technology, is centering the user. So you're thinking about what can I do to make the user solve their problem most efficiently. So here you're thinking specifically about sort of the problems, the needs, the focus of the stakeholders, and your design process is built to make it easy for them to solve whatever problem they want to solve. And so, as many of you actually have said this many times, but as you know, I think one of the potential consequences of the technology-centric design is everything becomes like a potential application of whatever tool you're building. Because again, you're not designing to solve a problem. You just have a cool tool or cool technology, and you just look for you search for an actual application where it's useful. The point is not that this has no place or is not useful. I think the point here is it's solving a very different problem than user-centric design, which is again focused on making making it easy for users to solve problems.
I think it's fair to say, like, chatbots, for example, they adapted a technology to solve a user problem, so it's user-centered in that sense. Mm-hmm. But then, because they aren't perfect at doing it, is when it becomes a little tech-centered, and you have to figure out how to prompt it. It's kind of both.
Yeah. So I said this a little bit. So two things. One, I said this. So one, for discussion purposes, I'm going to be somewhat extreme and say things like black and white. The real world really isn't, as you know. There's a little bit of partially design for real users. There's a little bit of targeting problems for problem's sake. I think chatbots are, again, a mix. I think my sense and a little bit of like knowledge is that they were, some of the design decisions made. Actually, we discussed this in this class in early lectures on how, for instance, if you're focusing on language models, in principle, the base model before you've done any of the supervised fine tuning or RLHF or sort of preference tuning, quote unquote, this is analogy, complete, but our best understanding is that it has all the knowledge to do all the things chatbots do, but it's just extremely hard to interface with. And what supervised fine tuning and like preference tuning does is solve the interface problem. So it makes it easier for a user to get the model to solve certain tests, as opposed to, in principle, in fact, you can do this. If you have a big enough model, you can, the big models that you can actually, like, without doing supervised fine tuning and prompting, actually, like, chat with them. They're worse at chat, right? So it's still tricky to interface with, but arguably, like, and again, I'm analogizing here because I can help it because I don't have better language for this, but all the knowledge to do the thing is arguably in the model already, and chats are a way to close the interface gap. So I think in practice, it's a little bit of both. When I say both, the other side of this is I think, this class is an example of, we started with a user interface problem. We abstracted it out. It's still a technical problem. And most of what we covered in the class so far is pure technical, right? So, we're still interested in how this maybe eventually impacts users, but we mostly talked about tools. We haven't done that much like specifics on user settings where many of these might be interesting. And arguably, you could finish an entire PhD here on something like chatbots or user interface and never do a user study, just building better technology in a sort of pure technical sense. So that's maybe the other side of that discussion. Good question. Cool. Okay, so maybe to summarize, what is the point? So the idea in human computer interface is, again, to fill this gap between what people want to do and then how they can do this with technological tools. So one of the key approaches and sort of ways of framing how to solve HCI problems is what is known as design thinking. And so this challenges the ways of engineers, computer scientists focus on engaging with problems. So again, caricature, but the first approximation, I think, true, honestly, based on both myself talking with other people, like what actually excites you the most sometimes is the key technical problem. So you find some problem, and then your job is I'm just going to find a solution to this problem. So solution, and then maybe you want to write a few papers, and so you think of other solutions to the same problem. Your job is iterating over different ways of solving the problem. Design thinking asks to reframe this perspective. Instead of starting with, here's a problem, maybe somewhat stated clearly, what are solutions for some quantification, some operationalization of this problem. You take the problem and actually go back and ask why. And so, why is this a problem that actually needs solving? And you try to do this sort of over multiple iterations. It's sometimes called 5 whys. The 5 is not important. It mostly, 5 meaning 5 levels of sort of depth in this tree. The number 5 is not important. The key thing that's being encouraged here is to think very carefully and sort of deeply about what problem you really want to solve, so that you can identify it very clearly. What is the root cause of whatever it is that technology is meant to solve? So it's essentially trying to deeply or encourage going beyond surface level to deeper introspection. And we'll go through some of the tools that one can use to engage with this. And so, just to give some quotes. So it can go in multiple ways, but one version from Henry Ford is if I had asked people what they wanted, they would have said faster horses. So this is at the time before production cars were a thing. And you could have imagined the problem: people need to get faster from A to B. What is the solution? Well, we're using horses right now. Let's make the horses faster somehow. So you could easily imagine a counterfactual world where that was the thing that was optimized for as a solution. Instead of, say, let's think of some other tool that maybe solves the actual problem again. You can argue about whether this is the best solution. It is a solution. It is a different solution, arguably better solution than trying for faster horses. Other quotes. So within that design context, framing is often seen as a key creative step that allows the original solution to be produced. So designers report on the need to get the problem behind the problem when presented, say, with a problem by a client. So sometimes also called creating a fresh perspective. So you can feel free to read up on the quote and get to details offline. But what this kind of approach leads you to is, again, instead of starting with a problem and then going directly to, like, what are the solutions to this problem, you ask many why questions, like, why is this a problem? What can I do to, what is the root cause of this issue? And this pushes you in a maybe different direction. And so to operationalize this, one of the popular methods is called double diamond method. So the first diamond is the sort of problem diamond. This is where you're asking all the why questions. And then the solution is itself another why method. And the reason it's called a diamond is because you intentionally start divergent first. So you ask lots of questions with broad scope, and then hopefully eventually converge into a small set of things, or a thing as sort of root cause in terms of specifying a problem. And similarly, you can do the same kind of thing on the solution side. So divergent, all the different ways you can engage. But the better you understand the key root cause, and then also the affordances of the users and their context, the better you can identify a good solution for that context. So in a bit more detail, the sort of divergent part of the finding the problem is sometimes called discovery. So things like research. And then you define specifically root causes, so sometimes called synthesis, so you're combining things together. And then on the solution side, you have this ideation step where you're developing a bunch of different ways of thinking about potential solutions to the problem. Then you implement or deliver. The final solution typically will lead you to one thing as maybe your best sort of potential solution to this issue. So for this first step, again, discovery step, so lots of tooling out there, and many of our colleagues do this. I think, again, across all of science, across all of sort of work that engages with people, but within computing, I think the HCI areas are the ones that do this most. Education, I'm sure, does a ton of this as well. This could include things like field studies, interviewing people, surveys, You try to understand environmental factors, context, different needs, things like education of people, as you talked about earlier, market research, what are different stakeholders, all these kinds of things to get a sense of, to get a better sense of the why underlying the issue. And then once you have a good range, good understanding of the broad scope, then you try to narrow down to the root cause of the particular issue. So you try to, some of the techniques that are useful include things like participatory design. So you talk to a bunch of stakeholders, maybe jointly together, to get a sense, or try to see if there's a way to get to a consensus of the actual issue and maybe the root cause of a particular problem. You could use analytical approaches, so learn about relationships across the different tasks, or people give you lots of causes. You think about things, ways that can be grouped together logically. So they actually may be describing the same thing, but in different ways. Things like affinity diagrams, similarly, to help you think about groupings. And again, the hope at the end of this step is that you've identified a specific, or at least a small set of root causes that are at a, for analogy's sake, at a sort of deeper level than the original specification of the problem, which can be sort of vague and not, again, the horse versus car analogy from earlier. On the solution side, while you're developing, so you could, some of the tools that are used in this areas include things like storytelling. So you construct situations where the user is in a specific context and you think through different ways that different solutions might engage with the user in those settings. Prototyping is often useful, so build quick and dirty sort of solutions quickly, get a sense of to what extent does this actual solution meet the need as stated in context for the users that you're evaluating. And eventually you try to get to some minimum viable product, so something as a sort of synthesis final solution for this process that hopefully meets the need at the root cause level. So as mentioned, again, discover the problem, define the problem, develop the solution, and then refine or deliver the solution. It's worth stating that while this is a useful mnemonic or sort of conceptual framework for thinking about solving problems, in practice, many interesting things, and both in terms of research, but often in terms of things like products, it's not a one-time process. So often it's iterative, where you observe, you generate ideas, understand root causes, prototype solutions, test them out, and so that tells you, you deploy the solution, you figure out what you're missing, observe again, and so this you can imagine as a sort of iterative solution. And so one conceptual way to think about this is instead of as a cycle, you can think about it as an expanding loop, because again, over time, you're expanding the ways that hopefully you're better engaging with the problem by, if you like, along the time axis anyway, spiraling out to think about solutions to real-world issues. Okay, so this is at the conceptual end. For us, and for this, at least closest to this class, is what things like this mean when we're interested in human-AI interaction. So more and more, this is being formalized as a field, sort of actually at different levels of abstraction. People have decided to name this. So there's at a level of human-AI interaction, there's a level of human LLM interaction, human VLM interaction. So people who think of their work as sort of narrowly within some of these scopes, and the kinds of possible solutions that one can solve. I guess it's partially technologist in the sense that you're anchoring on a particular technology type, as opposed to let's just solve the problem. But it's a useful way maybe of organizing a set of skills and a set of tools and the different ways that one could solve useful problems with those tools or skills. So one way to think about this is an area or a field, a subfield maybe, where humans and AIs interact. The humans include AI researchers, model developers, domain experts, but also end users. And so each one of these will have different needs, different goals, different, again, context matters a ton. And one will be thinking about how to build solutions for each one of these potential end users. And then the AIs, here we're focusing on things tied to, well, lots of different contexts, but I already talked about large language models, but there are other kinds of tools, dialogue, audio systems, recommender systems, autonomous driving, pick your technology area, or in this case, AI area. And you can think about ways in which there are sort of new kinds of problems that combine different humans with different technological tools for solving some different real world problems. And then the interaction part is maybe the key new thing here is thinking about different ways of how that interaction might go. So it could be collaborative, it could be assistive. The AI is trying to assist humans solve something. There's the understanding, maybe to your earlier point. Humans try to understand AI tools. So you can imagine helping various ways that you can think about what the interaction might be. And so at a high level, the field tries to set itself up as, again, thinking through different human stakeholders, different potential AI tools or technologies, and then think about different interaction mechanisms and ways that you could bridge between these to solve real problems. Okay, so how do you solve this? This is, in some ways, the key bits. So the first step typically is figure out who the human is that you're trying to engage with. Could be you, could be typically the researcher will have agency to, at least in the research setting. Of course, in a product setting, it's different. Maybe the product defines who the stakeholders are. Research, you often have some agency there. And then also the AI, say language model or whatever else, which typically already exists, but needs some improvements to make it easier to bridge this interface gap. And so some of the key steps are things, first the design step. Why should they interact? What needs to be done to make it happen? What instances, what context, things like that. Enabling the interaction. So how can we enable this sort of, depending on the setting and context, what can be brought to bear to make this interaction easier? I'd argue that most of the work in this middle is about tooling. And most of what we've covered in this class are, in some ways, you can think of as tools that you can bring to bear to make the interaction problem easier. So this enabling the interaction question. So things like, can I better understand, or can I ease the burden of the interaction by personalization, by getting pairwise preferences from people? We mostly covered pairwise preferences, but we'll cover here briefly other kinds of ways of getting like choice or other notions of preference from people. All is thought of as technical tools that enable this interaction between AIs or humans and AIs, broadly defined. And then there's the evaluation step, which we haven't talked a lot about, but I think is super important. So we'll spend a little bit of time today talking about some of the ways, particularly when I contextualize what we've been covering in the broader scheme of simplifying the engagement between humans and AIs for particular problem settings, what evaluations could look like, different ways of thinking about evaluation tools. I will say, this is, we're covering this in an hour and change, like almost everything we've covered in the class, honestly, but yet again, I'll say what I say almost every class. This material itself is part of like a 3 or 4 hour tutorial. This is part of entire disciplines to spend people who build their careers around, or more and more so anyway. I think LMs are newish, but still there are people whose PhDs are about this. So there's a lot of depth potentially here. So if you're interested, I'm happy to give references. I have a little bit at the end here, the references sprinkled throughout, but there's a lot of depth that one can go into. But I'll try to give sort of enough of the stakes of the area so that you can find more material if you're interested. Okay, so first on the design. So here I'll say a little bit more about our favorite tooling, which is prompt engineering. So from a human computer interface tool, it's interesting and has been studied and thought of as quite challenging actually as a way to interface with AI technology. Arguably, what it's meant to do is, traditionally, what user interface designs are meant to do is to go from some high uncertainty problem-solving context to make it easy such that the sort of clarity and focus, very clear what the interaction should be to solve a particular task. Prompting, as cartooned here, and so cool paper with the figure that you can look in more detail. But you start with high uncertainty, maybe you reduce the uncertainty a little bit, by trying some prompting strategies. We talked about, people talk to each other, you sort of come up with best practices, but it's still a little bit brittle. Uncertainty still exists. And so you try different tools, and then, new things happen maybe in the tooling, or the context changes a little bit, some of the brittleness. And so you have high uncertainty again, actually. Some problems that you thought were fixed come back. Say, I don't know, OpenAI changes the version number under the hood if you're using this for your tooling. I'm assuming the nodding is people's lived experience. I certainly have had that, where we built something built on, I don't know, some version of ChatGPT, and something changed under the hood, and your solution completely breaks. But even this happens easily even with like open source tooling, because again, technology is evolving all the time. All kinds of unknown problems, new issues show up. And it's kind of hard to get to the point where, and arguably we haven't solved this in a general context-free sense, of getting to a point where we'll get to sort of ease of interface and sort of clarity in the way that you would argue that you often can get to in a standard UX setting. So some of the ways, or at least some of the description, is that the language interface, while it's freeing and makes it easy for you to, in principle, to our earlier comments about chatting, in principle, it makes it easier for people to interface with AI technologies. From a let's solve real problems point of view, arguably causes lots of new challenges, because it makes it hard to get to the sort of UX outcome that one typically tries to get to, which is, there's a clear interface approach that has low uncertainty and high reliability. So one quote that some of you might like is that prompt engineers exist to tickle ChatGPT in the right spot so that it coughs up the answers. I think many of you might agree with this, as at least some of the ways that you can think about prompt engineering. So you can think about adding references, saying things really nicely, playing with the framing, how much these other strategies that people try to use to get language models to solve problems as they would like them to. And so in real settings, you often need to engineer this, lots of engineering in the way that you frame, say, a prompt, enough that it actually starts to look a little bit like command line languages, where essentially you need a format that matches some templates to have any luck, I guess, in anything that's non-trivial for prompting. So again, many successful implementations of prompting and language models actually, in principle, should be natural language. In practice, are sort of highly stylized, specialized things, because this is what the thing you need for the tool to actually solve the problem you need to solve, at least to some level of reliability, often, again, not perfect. Okay, so one way to engage with this, and I'll give one example from colleagues that wrote this talk, is think about maybe hybrid user interfaces and ways that maybe adding GUIs in the middle of prompts can make sometimes improve usability. So I'll give an example in a sort of visual language model kind of setting. So trying to prompt things so that you can, say, better create images that match a certain design goal. Okay. So in this work, there's a reference at the bottom called Prompt Charm. The first thing was research. So this is part of the design example that I talked about, to better identify what the gaps are, what the root causes of the issues are. At the end of their research work, they found from user studies that there's significant conceptual gaps when a novice user writes prompts for image creation. In many cases, users have a clear image or style in mind, but they have a lot of trouble articulating it in the prompt in the right way so that the model does what it would like it to do. And so to solve this problem, this paper went through a few steps. Identified 5 major user needs and then a few steps to address the problem. So first being automatically recommending and revising text prompts, balancing automation and user control, various kinds of exploration to make it easier for users to explore, different ways of framing prompts, or at least engaging with the AI model, various kinds of version control so that users can go back and so see if something broke, you can go back to sort of what worked earlier, so making that easy. Trying to provide explanations for generated content so that it's maybe easier to see what might have worked and what can be done. make it easier in the future. So based on this research, they developed a new design. The first step, again, was this, or one of the first things that they tried was automatic revision of prompts. So many of you know this is now standard, actually, in many commercial language models. They don't show this to you. It's maybe a separate conversation. But almost always, or at least in models that prompt chatbots to create images, I don't have a percentage because I don't know the IP of the companies, but I know specific examples. Many of the language models have something in the middle that rewrites your prompts in a way that is more likely to work. This is like the engineering that gets the VLM to get the right solutions. Here they exposed it to the users. So you say, hey, I want a painting of a wolf sitting next to a human child in front of the moon. This might be expanded to, say, give a specific style, so a particular kind of artist in your style, and maybe something about this is trending on ArtStation, so a particular platform, like something that looks like something that they imagine the user might want. This is also ability for the user to change the terms, so there's a rewrite, but it's exposed. If the user thinks that this doesn't identify what they want, it's made easy to revise this to sort of change the prompt in a way that better matches what they need. The GUI also includes easy ways of finding similar items. So, if you don't know your artist super well, or you can't remember a particular artist's name, maybe give you suggestions for different kind of artists or different kinds of styling. And hopefully some of these word choices match your mental model of what you like. They also enable weighing of terms, which is kind of cool. So again, technology allows this to sort of upweight or downweight various aspects of the prompt. And they expose this again to the user. So the user wants to emphasize more or less particular terms. You have the ability to click on a word or a phrase, or in this case, the style, and then up or down weight, how much that is an important part of the provided solution. Okay, next is support exploration. So make it easy to play with, again, I already talked about the rewriting and engaging with the prompting types, but also things like quick prototyping. So GUI dropdown, you have a particular kind of style. You quickly iterate on it, maybe iterate on various kinds of the same thing. This helps you maybe pick the one that you prefer better. I actually wanted to look a bit more photorealistic. So I'll pick a photo based on a quick prototype of some early. So you can do this cheaply by doing maybe small, low resolution versions of the image and things like that. And this works really well with the diffusion technology itself. So actually this ends up being a good idea. You also make it easy for users to track what they've done. So if you want to go back, I don't have this here, but so step 4. And then I think another cool thing they tried here is to try to provide explanations. Again, I think technology is okay on this, at least enough to be usable, so for different terms, you try to figure out which parts of the image correspond to those terms. Users can modify how important they want different terms to be. The explanation helps with building mental models and mental maps of what technology is doing, enough that intervening and manipulation is quite a bit easier. And then they also allow for direct manipulation. So, I want to remove an object, say this mountain in the background. I can select with a simple tool and then inpaint with this background. I can add things all the stuff that, again, I guess now our standard tooling, actually don't know. Okay, this is a recent paper, but still, Adobe lets you do stuff like this, for instance, in many of their tools. But as an argument for how you can make it much easier for people to engage with this prompt generation technology, as opposed to just write your prompt and then spend your whole PhD figuring out the right prompt to get the image to work. So, I think a good example of what it might look like to make it easier. Yes.
This is more of a thought, but it feels just like a fundamentally pretty hard problem to solve. Someone has this picture in mind,
Indeed.
how do they put it in words?
Indeed.
It seems interesting that technology, it's something that you can't even another human. If let's say someone was I guess in the the police, like sometimes you like draw a sketch of like a criminal if someone saw them. So like that process maybe could be made better with this. I don't know.
Yeah, this is interesting. As an application, I'm hearing this is an application of technology like this, as opposed to. So it's sounding like you think this is a cool idea.
Like it's
And then what are the other ways you could use this?
yeah.
I'm happy to agree with that. I think that sounds right to me as a cool application. Yes.
On the slide before where it was like, oh, this is how this image corresponds to those
Yeah.
words, is that like after the fact or some kind of like attribution? I'll read the paper.
Yeah. They used my understanding is a post hoc, the paper at the bottom, this interpreting stable diffusion using cross extension. You know, it's better than nothing. I think interpretability tools are still, there's some work, I think, to make them fully robust and stable. For these contexts and the settings that they played with here, I think they work quite well. But it's not perfect. And I guess the issue has always been how robust they are. So it's a different technology problem that we still also, as a collectivist community, still need to solve. But I think there are tools that seem good enough for people to start, like building into interfaces, for instance, people to start using. So, yeah. But yeah, well, you should get the slides. I apologize. I tend to do them after the lecture. I really should. Oh, we're almost done with the course, but next year, everything will be ready at a time. But yeah, you can get the references. So you should be able to look offline. Okay, other thoughts? Okay. So, data some evaluation as well. We'll talk a lot more about evaluation in a little bit. Looking at various tasks and the accuracy of the users on these tasks using their tool versus other approaches that they could have tried. Okay. So, building interactive systems, good ways to think about it have lots of different components. Some of it include thinking about who your stakeholders are. So thinking about human cognition, perception. The more cognitive loaded the task, the more you want to make it easy for humans to be creative so they can engage meaningfully in sort of complicated cognitively loaded tasks. So like the example we just showed. There's a lot to be said about trust and reliance on sort of the technology that you're building. So, you want to ideally build a tool such that, if appropriate, users can depend on it to actually solve reliably the task that the tool is meant to solve. Reliability can play a huge role, and sort of calibrated trust can play a huge role. And getting that right can be tricky. I'll do a quick slide on it, but I think mental models often over or undershoot in trust. So users either trust too much and sort of don't appreciate the corners of where the tool can actually work, or they have one bad experience and then think that the tool is garbage and don't actually figure out where the tool is useful. So getting the trust calibrated is itself, I think, a challenging part of good user interfaces. Other aspects of building tools broadly in the world, things like accountability, fairness, transparency, ethics. We'll have a separate lecture that spends a bit more on these kinds of topics. But you want to build tools ideally that works for a broad range of individuals, and in particular doesn't perpetuate bias or discrimination or based on different stakeholder groups as much as possible. As I guess normatively for many of us, I think thought of as a good design goal. And then things like personalization, adaptation, and giving feedback easily, things like guiding interaction so that it's easy for particular individual users with their preferences and needs to engage with the tool, maybe to your point also, maybe even learn how to engage easily, but make that as friction-free as possible and improve over time to better align with human preferences. Okay, so a bit on some of the details. So things like trust and reliance. So as already mentioned, trust is some evaluation of the belief or confidence in the reliability, integrity, honesty. It's really a human property. I think more and more we apply the same analogy and concepts very directly to machines, to things like AI agents. Reliance is another property thinking about depending on someone or something to perform a specific function or task, irrespective of whether trust is present. So in some sense, they're distinct from each other. You can have lots of differences, this 4-quadrant thing between humans and maybe a human decision maker and the AI tool they might be using, where if a human decision maker always rejects the AI decision, but the AI decision is correct, then there's an under-reliance problem. If it always accepts the AI's decision, so it's automation bias kind of thing. Well, if it accepts and it's correct, then it's good. So it's appropriate reliance. But if it accepts almost no matter what the AI says, particularly when the AI is incorrect, then it's over-reliance problem, often sometimes called automation bias. And then if it rejects when it should, that's also appropriate, so you get appropriate reliance. So some of the challenges here include trying to design the overall system such that you're in the green parts of this setup. So I'm not going to go into technology. There's a bit more in the reference material, but mention this as the target of good design. I guess I will go a little bit. So one way that you could do this, sometimes helpful, is things like explanations, as we talked about briefly. Sometimes showing uncertainty helps. I think the research is still open on this. But there are ways to, I think the research is open because the way people understand uncertainty is still tricky. People tend not to be good at actual percentages. They bucket into big ranges, like low, medium, high is roughly, at least my understanding of the best research in this space. But still, showing uncertainty can be a useful way to better calibrate the user to what the AI is actually good or bad at. Allowing the user agency to maybe decide when to see results, so allowing for sort of self-prompted suggestions as opposed to things that are automated. Showing the processing, so showing that there's work happening actually sometimes builds good mental models for people instead of how easy or hard certain tasks are. So even though it's in some ways it's a bad thing because people are waiting, but it can actually be good in that it can be a way to calibrate on effort or difficulty, maybe effort is not the right word, difficulty of a particular task, and can help people build mental models to then have better calibrated trust. So some tooling, a bunch more others, good references on thinking about some of what we know about making this better. Questions on fairness, accountability. So fairness questions, again, making sure, as a normative goal, thinking about tools that don't behave very differently, say based on things like gender or sex, other kinds of demographics, socioeconomic factors. So tools that can work for various diverse populations. Accountability here measuring, so for example, in thinking through consequences of mistakes and then building that somehow into how you evaluate and build systems. So for instance, things like mistranslation can be a low risk thing. And I don't know, you're playing with the chatbot model. Can be a high risk thing if this is a translation used for decision about asylum, for instance, in a different language, right? This is someone's life. Some big life decision that a translation error can make a huge impact on. And this happens, actually. It's a big issue. So getting that right and calibrating that correctly for, normatively we want the tool to be as good as it can be, but also, when it's not good, we want the stakeholders to understand the gaps in the tool. So the user themselves to understand it, say the judge or other parts of the legal system to understand it. The better you can achieve that, the better you can have better accountability and sort of correctly place accountability for good and bad parts of technology tools. Transparency can often be useful. I think this one is somewhat, well, it also is a big bucket, transparency. And what I was going to say is it's slightly controversial as well. In the sense that I think one argument that's made all the time is that you shouldn't trust models that you can't understand. I think, again, sorry, coming back, but the comment you made earlier about how well we understand AI tools. There's a counter argument that we actually don't understand lots of things we trust. And the example people like to use a lot is like aspirin and medical things that, we know something about the outcome. We don't know the mechanism actually all that well. I see some surprised faces. Go look it up. It's actually fun.
What is it again?
Aspirin. Yeah. But there's lots of other sort of Most doctors, for instance, don't understand the MRI in any kind of technical detail. They understand input-output enough that they can use it for decision making, but they're not physicists. They have specialized physicists in the hospital whose job it is to like understand the MRI. I don't know where the field will land, but that's maybe a separate question. I think what's useful here is to say that it can be a useful way to calibrate user interfaces, is, if possible, explainability, transparency of things that are going on under the hood can be useful. And then also ethics. So we talked about this briefly, but thinking through various kinds of interactions between humans and AIs and what they mean in the context of broader world. And maybe, again, different ethical perspectives from different stakeholders, thinking about ways to bridge between the ethical perspective of the humans and what the AI tools can, I guess, to what extent can we have decision-making from AI tools match human ethical principles and values? Again, part of the goal of the broader classes we've talked about. And we'll spend a little bit more time on that, I think, a couple of lectures from now. Okay. In addition to thinking about what we would like in good interaction design, is also thinking about who starts or how the interaction gets started. So on one end, it's the sort of human as the initiator, so human as a creator, using a computer as a tool, and your goal is to sort of make it easy for the human, for instance, to be creative. As would be one potential outcome. The other might be a computer initiative. So a computer is sort of deploying something, maybe automatically. So human is the audience, computer is the creator, and here your goal is to make the computational outcome creative such that it might meet the need. So you can imagine, for instance, things like, controversially, but I think true, like automated things like art and things like that as examples of cases at the other extreme. Many real world things are somewhere in between with some mixed initiative. And I think increasingly there's interest in thinking through more carefully what collaborative human AI interaction looks like, where both sides are collaborative, there's some mixed initiative potential outcome. How do I make it easy for that to happen? So mixed initiative systems allow for collaboration where the user and the system both take an active role in carrying out tasks and making decisions. And to do it well, you have to couple sort of automated services with various kinds of direct manipulation that encourage creativity. So you could do this, for instance, by creating automated agents that take actions only when the agent believes, anthropomizing a little bit, that they will have greater expected value than not doing anything in a particular context for the user. So again, more detail in some of the references in the rest of the text. But just to summarize some of what we've said about interaction design. So ideally, you can make it seamless without necessarily having explicit instruction manuals. Some of the ways they can do this include thinking through how humans interact with the world and extending those affordances, sort of, or at least standard interaction mechanisms, making it easier for those to match well with what the algorithm is expecting. Design thinking is very helpful. Things like finding the root cause of a problem, finding solutions, iterating back and forth, so that you can ideally build applications that users actually want to use as opposed to have to, perhaps. And then beyond the human factors that are about usability, there are also sort of maybe unseen human factors, things like psychological and cognitive aspects, underlying trust and reliance, implications in the real world, things like ethics and fairness and the other issues that we talked about briefly. Okay, so I'll switch gears here for the last 10 minutes or so. I'll talk about evaluating human AI interactions. So some of the key questions that you want to be asking when you think about evaluation are, the how, what, who, when. So how are we evaluating, what is being evaluated, who is doing evaluating, when do we evaluate? So on the how, there are a bunch of different directions that one could go. The key ones being on the methods, on the types, and on the metric types that you might pick. So methods, things like quantitative evaluation, which is, I think, what we're best at. You find some number that quantifies what you hope will happen in the task completion, things like that. how many questions did the model answer correctly? Did the user complete the task? How long did it take? So there are quantitative evaluations. Qualitative evaluations are more open-ended. You do things like surveys, ask people, or try to think through what are some reasons that the model answered some questions incorrectly. What did the user or stakeholder group like about the experience? Were they frustrated? So often in a good design study, you do some kind of qualitative evaluation. This gap is striking in, I think, language models because, as many of you know, the quantitative evaluation, particularly via benchmarks, are, again, somewhat precise in ranking models. People's lived experiences with models often diverge from what the benchmarks say. So often this can give you quite different information. When there's a gap, at least my personal perspective is that this says there's some issue with the quantification, and so we should make better tooling on the quantification side such that it better captures what people like about tools. But I think the key point here is, in terms of evaluation, both kinds of evaluation actually carry signal and their importance in their own right. Both the quantitative, turning things into numbers, that we can then use to compare, rank, select, things like that. And then qualitative, understanding the why, perhaps open-ended, that we can then synthesize into hopefully better ways of measuring, is, at least in my mind, often one of the useful use cases of these. Okay, there's also an evaluation side thinking about types of evaluation. So there's intrinsic evaluation, which is we just take the model on its own, have an NLP model. Again, benchmarks do this. I just want to understand how the model works in a specific task directly related to the model's performance. So this may or may not involve users in any explicit way. There's also, so, you can imagine log likelihood or like benchmark completion in that sense. There's also extrinsic evaluation. So how helpful is the model in some real world, ideally downstream task? So you're evaluating it within the context of some use case. So, if you're building a coding assistant, you're evaluating within the coding context as opposed to generically, having a database of code completion tests that is a benchmark. And you can get, very different signal in the intrinsic abstract evaluation compared to extrinsic within use case context evaluation. So both can be very valuable. Intrinsic tends to be faster, because you don't have to build it into the experience. Extrinsic can be slower, but can often reveal gaps in the intrinsic. So again, very useful as part of the evaluation process. And then finally, things like metrics. So over time, there's work in trying to validate a set of different metrics. There's quantifications of various kinds of tools. So quantifications, for instance, of things like productivity, things like how many lines of code was added in a certain coding tool. So, sorry, you have a coding tool, you have a human engagement coding tool, you measure lines of code added as a quantification of productivity, for instance. Things like costs, how much did it cost for adding this tool in some larger context of cost. Some of the choices here include, do you rely mostly on existing validated metrics, or have you done some work to say that this is a good metric? I'm saying this from the paper, by the way, that's referenced at the end. It's a good read. I'm thinking about evaluation of pair programming, human AI pair programming. Do you try to come up with a new metric that maybe better captures the context? Some important design decisions in trying to build evaluations. On the what is being evaluated, so again, it can be the model, it can be the HCI, it can be whole end-to-end. Often these are separate modules combined together to solve some task. So in the code review case, code is a good one. There's a tool called Critique. And the reviewer asks for sort of some defensive coding practice. The author, the model acts as a reviewer. I guess you can have either way, model or reviewer being the AI tool. And you have, within this, say different kinds of things like different colors to identify parts of code that should be added or removed, things like that. The key point here being there's an underlying technology under the hood. There is a sort of HCI interface and ease of interaction with the tool. And there's also the end-to-end. And so in evaluation, often you would most good evaluations do these things separately and then think about the end-to-end is the whole thing. So you have that as part of it. You can also think about different goals of the evaluation. So things like utility, satisfaction, a whole bunch of different goals. So here, I have some different code snippets. You can ask a metric that looks at whether the code passed or didn't pass some test, or you could ask how close is it to some reference code, so just similarity matching between the text. Or you could ask, a human to give preferences on the code outcomes and get a sense of, did the human like the new code? Again, different ways of measuring. So different goals that you could have in the evaluation process. And again, any good study design has lots of these. Again, hopefully it's clear. It's a huge design space of evaluations. A bunch of work thinking about all these. I think good studies will tend to pick a subset of these that are most relevant to the context and think about how to implement, so operationalize these choices in an evaluation process. And finally, you want to think about, finally, who is evaluating. So it could be lay users, it could be a domain expert, it could be some kind of automated evaluation. Things like LM as a judge is more and more popular. So this ties to this question. It's tricky to design systems to work for everybody. I say everyone here, not in a, so I want to separate out everyone in terms of demographic bias of various kinds versus other kinds of, say, stakeholder groups and stakeholder settings, which should be distinct from things like demographics and socioeconomic factors. So for instance, is it an expert group? Is it are these lay users? Are there sort of use case specific things like teachers in education settings, parents who are trying to engage somehow with the tool, students who are trying to learn something? So the target group will make often a big difference or big impact in how you should think about the evaluation process. Again, more details in the reference material. Okay, finally, I said finally, but I was wrong. This is the actual finally. Is when to evaluate. I forgot there were 5 things. So, different timescales. There's instant evaluation at the time of interaction. There's some kind of short-term interaction. So you look at a few rounds of things. There's long-term. You try to build a tool, deploy it for some, say, a week or even longer. There are tools you can try to implement and deploy it for weeks, months, years, see what impact they might have. So you do long longitudinal studies. Again, some important design decisions that need to be made when one is trying to build evaluation tools for human-computer interface, in our case, specifically human-AI interface design problems. Okay, so let me summarize. So we talked today about sort of human-AI interactions and think about the design decisions tied to this, both some of the motivation foundations, work in HCI that deals with this, implications of this kind of work, and some of the ideas on how to implement this. And arguably the goal is that if one does this well, then you can harness various kinds of AI techniques in ways that actually solve people's problems and respect people's needs, goals, and values in real-world contexts. We talked through a few different perspectives, one on enabling human-AI interactions, so things like various ways that you can help AI tools continue to learn from interactions, things like preferences, interaction settings that maybe help to the tool be more personalized. For instance, things like social choice as an alternative to high personalization, calling back some of our tooling from the class so far. And in various ways to do the analysis and what impact it might have on decisions for different stakeholders. We then talked about evaluation. So this is thinking about this mapping between use cases, the user, various kinds of evaluation mechanisms, things like sort of different lengths of the evaluation process, qualitative versus quantitative evaluation. So other questions are part of the design decision and now the design of the evaluation. So evaluation itself becomes a design problem, like picking design setup for the evaluation that best matches what you're actually trying to build, what was the best fit for the context. Okay, so that's that on what I wanted to cover. We're about at time.